Okay, I will continue from the previous class. So I was from in the previous session. So we had reached to a stage where we had written the formula. Let me quickly write. We had x and y. We had this was 0, this was 0, this was 1, this is 2, this was 2, 8, 3, and 27. Okay, these were the different values of x. Correspondingly, we were given different values of y. And now we had to say what is the value of y at x is equal to 2.5. At x is equal to 2.5, what is the value of y? That was the question. Now we had started with the Lagrangian interpolation, and let me write down now. At x is equal to 2.5, our y1 is 0, so the entire y term is 0, plus y1, that is 2, multiplied by x minus x1, that is our x is 2.5, minus x1, that is 0, multiplied by x minus x3, okay, that is 2.5 minus 2, and x minus x4, that is 2.5 minus 3, whole divided by x2 minus x1, okay, x2 minus x1 is x2, so x2 minus x1 is 1, multiplied by x2 minus x3, x2 minus x3 is 1 minus 2, and x2 minus x4 is 1 minus 3, okay, plus y3. Our y3 is again our y2 is 1, sorry, here is a correction. Our y1, this is y1 is 0, y2 is 1, then we'll write y3, and y3 is 2, okay, so we'll write this y3 as y3 is to be written as 2, multiplied by 2 multiplied by x minus x1, that is 2.5 minus 0, multiplied by x minus x2, that is 2.5 minus 1, x minus x4, that is 2.5 minus 3, whole divided by x3. Our x3 is here, okay, our x3 is here, x3 is equal to 2, so it is x3 minus x1, that is 2 minus 0, multiplied by x3 minus x2, that is 2 minus 1, so this is x3 minus x1, x3 minus x2, and x3 minus x4 will be 2 minus 3, okay.
So, hello, sir.
This will be x3 minus
Sir,
2 minus 1, so this is x3
sir, I have
minus,
a question, sir.
just a minute, so we have x3 minus x1, x3 minus x2 is 2 minus 1, and we'll make a correction here that our y2 is equal to 2, and our y3 is in fact equal to 8, so we have to make a correction here as well. Y3 is equal to 8, okay. Now we'll go to the last term, that is y4. Our y4 is 27, so it is 27 multiplied by x minus x1, that is 2.5 minus 0, multiplied by x minus x2, that is x minus x2, that is 2.5 minus 1, x minus x3, that is 2.5 minus 2, okay, whole divided by x4 minus x1, that is 3 minus 0, x4 minus x2, that is 3 minus 1, x4 minus x3, that is 3 minus 2, okay. Now we'll solve this, so that will be equal, this comes out equal, as I solve this, this comes out equal, can we quickly solve it? This comes 15.313, okay. So we can add on to our table, we can write in our table as the value of x is 3, the value of y is 27, and as the value of x is equal to 2.5, at the value of x is equal to 2.5, the value of our y is 15.313, Okay, so it was like we were given the data, we were given the values of x initially, okay, and corresponding values of y. Then all of a sudden we were given some value of x and we were asked what is the corresponding value of y for it. Okay, this is what happens. For example, you are playing cricket, and for example in first hour a player makes say for example in first innings a person makes, say for example, 20 runs. In second innings he makes 15 runs. In third innings he makes 10 runs. In fourth innings he makes, say for example, 5 runs. And in sixth innings it's given to us that he makes 100 runs. Now the question is, if what how many runs he must have scored in his fifth inning. Okay, that is a question. So we are given in innings one, in first inning, this much was the score of a particular player. Now we are not given in his fifth inning how much he scored. Now we are questioned if the number of innings is five, in his fifth inning, how much was the score? Okay, so we can make use of this Lagrangian interpolation to find the value of the score in his fifth inning. Now the question is, we use this formula, okay, for calculating the values of y at a given value of x. The question is how we obtain this value of, how we use this, how we derive this formula. Yes. Now we'll return back to the Lagrangian interpolation concept, how Lagrangian interpolation actually works. Now, it's like we are given the values of x and values of y. Let me write here. This is Lagrangian interpolation, in which we are given values of x, x1, x2, x3, so on up to n, and corresponding values of y are also given, y1, y2, y3, and these values are given up to yn. Fine. So if we start plotting them, so on one side we'll be having x, on the other side we'll be having the values of y, and there will be the graphs. Okay, there will be some curve that will be representing these values of x and y. So this is x1, this is y1. Similarly, you will be having x2, and corresponding value of y will be y2, so on and so forth. What Lagrangian suggests, suggests, let there be a function, let there be a graph, okay, joining all the given points. Okay, let there be a function of x, let there be a graph joining all the functions, joining all the points of x. Okay, and we write that as Lagrangian suggests, let that be as y is a function of x. Let there be a function of x. Let there be a graph which joins all these points, all these given points. Okay, so we are given n number of points. Let there be a graph having function y is a function of x is equal a1 x minus x2 multiplied by x minus x3, x minus x3 plus a2 x minus x1 int x2 minus x minus x3, okay, plus a3 x minus x1 and x minus x2 multiplied by x minus x2 divide, oh sorry, okay, this is what Lagrangian suggests. Let there be a function. So if you multiply these two, you have x into x is x square. So the polynomial is of second order, which is being suggested. Okay. Now look at the first term, which is being suggested. This is assumed. Okay. This is a1. This is the first term. So the constant is a1. Look here. This is the second term, and the constant is a2. This is the third term, and the constant is a3. Okay. Then we start with the first bracket. This is x minus x2 multiplied by x minus x3. So in the Lagrangian interpolation formula, in the first term a1, you do not have any term containing x1. There is no term which contains x1. Okay, but it contains the subtraction with rest of the terms. X is the value at which we have to find the value of y. So this is a1 x minus x2 into x minus x3 plus this is a second term a2. So it will not have a term containing x2. So it will be a2 x minus x1 into x minus x3. Same is the case with a3. Okay, such that at x is equal to x1, the value of our function is y becomes equal to y1. At x is equal to x2, the value of y is equal to y2. At x is equal to x3, the value of y is equal to y3. Okay, at x is equal to x1, the value of y is equal to y1. At x is equal to x2, the value of y is equal to y2, and x is equal to x3, the value of our y is equal to y3. This is also given to us. Fine. This formula, this is quite this we can easily understand, because x1 x2 x3 y1 y2 y3 are given. And be careful here that here we are reducing, here we are doing this interpolation for only 3 points. Okay, we'll use this formula, we'll derive this formula for 3 points, which we will then uh, define for n number of points. Right now we have taken only 3 points, x1 x2 x3 y1 y2 y3. So it means if we are given these points, so what will be the corresponding values? Okay, the corresponding values will be, I will say y1 is equal to, in this formula I have to substitute x is equal to x1. Okay, so it will be a1 multiplied by x1 minus x2 into x1 minus x3, x1 minus x2 into x1 minus x3. Now this term becomes 0 at x is equal to x1. This term also becomes 0. Therefore, from here I can say a1 is equal y1 divided by x1 minus x2 into x1 minus x3. This is done. Okay. In the same way, let's talk about our x2. Okay, let me clean this much. At x is equal to x2, what we can suggest? At we can write y2 is equal, well, we have to substitute x is equal to x2. Therefore, this term becomes 0 and this term also becomes 0. So it becomes a2 x2 minus x1 multiplied by x2 minus x3. Therefore, our a2 becomes equal y2 divided by x2 minus x1 into x2 minus x3. This is my a2. In the same way, let's talk about our y3. Let's talk about our y3. At x is equal to x3. Okay, at x is equal to x3, y3 becomes equal, now this term will become 0 because x3 minus x3 is 0. x3 minus x3 will become 0. It will become a3 multiplied by x3 minus x1 multiplied by x3 minus x2. Therefore, a3 becomes equal y3 divided by x3 minus x1 into x3 minus x2. Okay, therefore these values of a1, this value of a1, a2 and a3, let's substitute these values in our given function. Okay, so as we do it, it becomes, let me rewrite it entirely here. My y of x, is equal, first of all I have to write the a1, which is equal to y1 divided by x1 minus x2. Okay, so it will be, that will become equal to y1 multiplied by x minus x2 into x minus x3 divided by x1 minus x2 multiplied by x1 minus x3 plus y2 multiplied by x minus x1 x minus x3 divided by x2 minus x1 into x2 minus x3 plus y3 multiplied by x minus x1 into x minus x2 divided by x3 minus x2 into x3 minus x1. Okay, this is okay. We can write this as we can write this as. So see, what is the procedure of writing? I had 3 points. Okay, in the numerator I'm having 2 terms only. In the denominator I am having 2 terms only. When you have having 4 number of terms, x1, x2, x3, x4, in the numerator you will be having 3 terms, in the denominator you will be having 3 terms. Okay, now let's simplify this. We can write this as y of x. This is written as y of x is equal, we have y1, y2, y3. We write this as summation I going from 1 to 3 yi. Okay, summation I going from 1 to 3 yi. Okay, because I know that this will be y1 plus y2 plus y3, but not only that, you have a big term in the product. Okay, so the product term is written like this: product, we have j terms going from 1 to 3. I can write this as, this is x minus xj multiplied by, okay, not multiplied, x minus xj divided by xi minus xj. Xi minus xj. This is the shortest way of writing this interpolation. Okay, where j is not equal to I. This is I. So this entire equation can be reduced to this form. Now I can simplify it. This is the way of writing this, and this is what you call as, this is called Lagrangian. This is called a Lagrangian interpolation polynomial. This is called Lagrangian interpolation polynomial. Okay, this is how the Lagrangian interpolation. What do we mean by the Lagrangian interpolation polynomial? Now see how you have 2 terms here. Let me brief you about these 2 terms. You have a summation term and we have a product term. So when you expand it, how you expand it? You expand it first. You give I equal value 1. So you write y1. So you have to start from the value of I goes from 1 to 3. Okay, and your j also goes from 1 to 3, where j is not equal to I. So first you give the I the value 1, so it is y1. Then once this is done, once you have given I the value 1, stop, take the product, that is product. Then you have x minus, so j also starts its value from what? J starts its value from 1, but j should not be equal 1, so it will be x minus x2. Okay, and give rest of the terms x minus, take it again, x minus x3. Okay, if you have 4 terms, okay, you can go ahead, divided by xi minus xj. I cannot be equal to, your I cannot be equal to j. Okay, you have started, your j cannot be equal to I. You have started your I from 1, so it is x1 minus, j has to start from 1, but j is not equal to 1, so you will start it from 2, multiplied by, because this is in the product term, so that's why you are taking product, x1 minus x3. Okay, this finishes the first term, plus give y the value 2, so it is y2. You give I the value 2 and take the product x minus, j starts from 1, so it is x1. Okay, the next term, because you have a product symbol, x minus, you cannot give it 2 because I is equal to, you have to give it x3. divided by I is equal to 2. So it is x2 minus x1 into x2 minus x3 plus the third term will be y3. It will be x, it will be y3. Then in product, it will be x minus x1 into x minus x2, but not x3 because j cannot be equal to I, divided by x3 minus x1 into x3 minus x2. And this is same what you have obtained previously. Okay. Therefore, you can also write this Lagrangian interpolation formula for n number of terms, which I want you to do. So in the same way, you can write this formula for n number of terms. The description will be same. We can write this for n number of terms as y of x is equal summation I going from 1 to 3. Sorry, not 3 now. We don't have 3 terms. We have n number of terms. So I going from 1 to n. Okay, yi, the product term, j going from 1 to n, I is not equal to j. Okay, x minus xj divided by xi minus xj. Okay, so now if you have a problem like this, you are given x and y. X is equal to 0, y is equal to 1, x is equal to 1, y is equal to 2, x is equal to 2, y is equal to 5, x is equal to 3, y is equal to 4, x is equal to 4, y is equal to 6, and x is equal to 5, y is equal to 9. Okay, so you have n is equal, your number of terms are 1, 2, 3, 4, 5, and 6. N is equal to 6. Okay, find y at x is equal to 4.5. Now tell me, if you have x is equal to 4.5, what is the corresponding value of y? Okay, use the Lagrangian interpolation formula for n equal to 5 number of